So we got to take a break from solving quadratic equations because I got to teach you something that you've never seen before in your whole life. Is that good? Okay. First of all, let's review a little bit what we did yesterday because that's going to lead directly into today. Okay? Remember how I said to you, the square root of 16. What's the answer to the square root of 16? 4, right? And we're clear that it's just 4, right? But I said, what if we have x squared equals 16? How do we solve that equation? Taking the square root of both sides. When we take the square root of both sides, we get x equals, plus or minus 4. Why did we have to put the plus or minus? Because we put the square root, it's exactly right. We put the square root into the equation. This one, this was given to us like this, the answer is 4. Okay? So when we're put into situations like these things, we're confident in this now, yes? Square root of 16 is 4, but if I have to solve this, I would take the square root of both sides and I would get plus or minus 4. Okay? So here is something you've never seen before. Kind of. You've seen it. And when we got to it, you put, well, let's see, what do you remember? What did you put when you got that as a problem? Probably you put no real solution. Now, some of you less educated might have put no solution, right? But I corrected you and said, oh, close, it's no real solution. And before, you might not have seen a difference in that. Today, you're going to see a difference. Okay? Remember when we did radicals before, we can separate this into 2 parts, can't we? Remember doing this? Now, we didn't do -1 and something. We just did, if it was 32, we did 16 times 2, because I know the square root of 16, right? But I just separated this into 2 parts, because I know the square root of 9, don't I? What is it? 3. Guess what the square root of -1 is? We're going to put little tails on them. If we just put a straight up and down line, it looks like a 1. Even if we dot it, it still looks like a 1. Okay? So we're going to do little cursive, little crazy, little odd eyes. Okay? So here's what I want you to know. The square root of -1 equals I. Got that? So let's see if we can do something like this. What about this? The square root of -16. This is my favorite problem. What's the square root of -16? 4i. It just brings back memories. That was my nickname when I was growing up. I didn't say it was good memories. I just said it was memories. Right? Okay? So, 4i. Yes? So what about this? Square root of -25. 5i. So what about the square root of -32? I don't know the square root of -32. But I do know that -32 is the same as -1 times 16 times 2. Don't you know that? What's the square root of -1? I. What's the square root of 16? 4. What's the square root of 2? I don't know. Done. So up to here, if without the -1, we've done that already, haven't we? We spent some time on that when we first started talking about radical expressions. You remember that? So now we're just adding in a -1. We'll do one more like that. The square root of -75. I don't know the square root of -75, but I do know -1 times 25 times 3. What's the square root of -1? I. What's the square root of 25? 5. What's the square root of 3? Done. Yes? So here's the deal. This right here is an example of a complex number. Now, sometimes that scares people because one of the definitions of complex is hard, right? It's complex. It's very complex. So they're like, oh, it's hard. This is going to be so hard. Well, I mean, it might be to you. I don't think it will, but it might be. But what I want you to keep in mind is that one of the definitions of complex is multiple parts. Okay? Do you see that this has two parts? Here and here? What kind of part is this? It has an I in it, right? Did we talk about what that I stands for? It stands for imaginary. We won't be taking imaginary homework or doing imaginary quizzes or having imaginary tests. That's a different kind of imaginary. Okay? We're talking about imaginary numbers in math. Okay? This is the imaginary part. Oops. I forgot to put the tail. So what's this part? If this is the imaginary part, what's this part? The real part. That's exactly right. And some people are like, real parts and imaginary parts don't work together. And I'm like, Space Jam. Space Jam. That was real and imaginary together, right? And it worked. That was a good movie. Okay? Who Framed Roger Rabbit? Not so much, but that's okay. Right? They tried. Right? Any more that you can think of like that? No? But for sure, Space Jam. Right? Okay? You know they're talking about making another one, right? Okay. Yeah. So we have a real part and an imaginary part. So what we have to figure out is, are we allowed to do something like this? Except that's not supposed to be there. Don't write that down. Sorry. 2 plus 3i plus 4 plus 5i. Are we allowed to do that? Addition of complex numbers? How do you think I would go about doing that? So you're using a phrase we've used before in a different situation, and you're adapting it to this situation. That's amazing. That's really good. Okay? Not a lot of people can do that. So what she said was adding like terms. Now, are they really like terms? Is it really like x and x squared and x cubed and all that kind of stuff? No, but yes, right? No, it's not 2x and 3x that we're adding together, but it's real parts that we're going to add together and imaginary parts that we're going to add together. Does that make sense? Okay? So that was excellent. That was excellent using stuff you already knew, prior knowledge to go for today. Okay? So what is 2 plus 4? Excellent. Well, now we can do the imaginary parts. What's 3i plus 5i? Does it make sense that you can just add the coefficients of the imaginary numbers? Good. Done. Now, very rarely will you see it written like this. Why? Because the people 20,000 years ago, or whenever they came up with this math, they decided that when we write our answers, we're going to write what first? The real part. And then second, we're going to write the imaginary part. Okay? What do you think about this? Do you think we'll see it written like that? Why? Kind of goes back to how we write our variables, right? If we have a number and a variable, we typically write the number first and then the variable. Is I a variable? Are we going to substitute something in for I later? No. That is just telling us that this is the imaginary part. So even though we don't treat I like a variable, we kind of do. If that confuses you enough, then let me know and we can try again. Okay? I is not a variable, but sometimes we treat it like a variable. As far as like where we write it, what we can add together, things like that. Okay? So if we can add can we subtract? Yes? Okay. So what is 2 minus 4? -2. Because I took my two real parts and subtracted them, just like it says. So what about this one? 3i and 5i. Isn't that still just 8i? Oh, no? Why not? Oh, we're subtracting. What is 3i minus 5i? -2i. Any questions about that? So, if we can add and subtract... Oh, dang it. Can we multiply? Why do you think people don't want us to multiply? Because we're going to end up having to multiply what and what together? Real and imaginary. Space jam. It works sometimes. Okay? 2 times 4. That's not a problem, is it? That's real times real. That's just 8. 2 times 5i, people have problems with. Space jam. Multiplication is okay for real and imaginary. Putting them together works sometimes. What is 2 times 5i? 10i. What is 3i times 4? 12i. What is 3i times 5i? 15i squared. So we have to have another conversation. Because a second ago, I told you something that was super important. And I said, you've got to know this. You've got to know that I equals the square root of -1. I said that, right? You remember that? Don't I know what I squared is then? How would I get from here to here on this side? How do you get from I to I squared? You square it, right? That's exactly right. If I square this side, what do I have to do to this side? What happens when I square the square root of -1? -1. I squared equals -1. So what does this term really equal? That's exactly right, -15. Because this value right here is -1. What's -1 times 15? -15. Now what do you think I need to do? Now we can combine our like parts, right? Our real parts and our imaginary parts. Here's my real parts, 8 and -15. -7. Here's my imaginary parts, 10 and 12. 22i. Done. Questions? Good? So, let me go over this and make sure we're clear. Can you take square root of 9 and tell me that the answer is 3i? Can you do it without doing this step right here? Can you go straight from square root of 9 equals 3i? Good. If you can't, that's okay to write this middle step. But if you can go from here to here, go for it. Okay? Can you simplify terms like this when they don't have a clear square root? You okay with that? Okay. Can we add complex numbers? Subtract? Multiply? Okay. There's 2 more things I want to show you just in case. Okay? Because I forgot, actually, honestly, I forgot to talk about it back over here. Okay? So it's very similar to these problems. I think I'll even do it on this page right here. Okay? What if instead of having the square root of -16, I had 3 square roots of -16? There. What do you think I would do there? What's the square root of -16? 4i. What do I do with the 3? Multiply. What is 3 times 4i? 12i. Done. So if it has a number being multiplied to your root, can you do that? See why I forgot? Because it's just kind of like the next step. Sorry about that. Okay. Last thing I want you to know is this. What if I have 2x plus 6i equals 8 minus yi. And my directions to you are solve for x and y. What do you think I would think about in a problem like this? You don't have to tell me the answers, I already know them. I want you to tell me what you would think about. Excuse me. What has to be true about the real parts? They have to be equal. So 2x has to equal 8. So what's x? 4. Did that require any work in my head? I mean, on my paper. No, I did it all in my head, right? Is that okay? So what has to be true about the imaginary parts? Has to be equal. So what's y? Close. -6, right? Because of that sign right there. Did that require any work on my paper? No, I did it in my head. Could I do work on the paper? Yeah, I could have said 2x equals 8. I'm ignoring the imaginary parts right now, and I'm just looking at the real parts. So I wrote down 2x equals 8. Just divide both sides by 2 and get x equals 4. Oh gosh, I already got that. Could I do this one on paper, the imaginary parts? Yeah, I could say 6i equals negative yi. What do I do with the i's here? Kind of ignore them, don't I? Because I know they're both imaginary. So 6 has to equal negative y. Okay, y is -6. Any questions about that? Okay. Any questions about any of these examples I've shown you today? No? So I want you to use the rest of the time here in class to work on your homework, okay, in your workbook. So make sure you have that out. I have the answers pulled up on my computer. If you have any questions, if you want to check as you go, come and ask me questions if you have questions as you go. And let's see if we can't knock this homework out by the end of the period. Okay?